Okay, today we are going to talk about adding polynomials, and we're going to talk about the geometric application of adding polynomials. When we are doing so, we really only have one rule or one qualification in order to be able to add two polynomials. And that is that we can only combine like terms. Now, this is really important to know what constitutes a like term. Two things must be true. That term has to have the same variable, which remember the variable is going to be your letter part, and also has to have the same exponent. So the same variable and that variable has to have the same exponent. So that is going to be the stipulation that we need in order to add our polynomials. So if I look at my first problem, I noticed that I have 2x cubed minus 7x plus 3 plus negative 9x cubed plus x plus 1. So the first thing I want to do is I want to start with my very first term. So I'm looking at 2x cubed. Now, I can only combine my like terms, which means I'm looking for another term that has both an x, the same variable, and the exponent is 3 cubed. So I notice that in my second parentheses, negative 9 also is an x cubed term. So that means that I can add these together. Now, once we've identified our like terms, we are only actually going to add together the coefficients. So I'm only going to add 2 and negative 9 together. When I add 2 and negative 9, I get negative 7, and I keep the variable x and the exponent 3 the exact same. After that, I'm going to move on to my next term. So my next term is a negative 7x. So notice here that our variable is x, and the exponent is an understood 1. So I'm going to look for other x terms with the exponent of 1. And I notice in my second parentheses, I also have this positive x. Remember, there's an understood 1 in front of this x, which is helpful to know because, again, once I've identified my same variables and same exponents, then all I have to do is add the coefficients. So negative 7 plus 1 is going to give me negative 6, and I keep my variable and exponent the same. Now the last term in that first parentheses is a positive 3. Notice that that does not have a variable or an exponent, therefore it is called a constant, and I can add all of my constants together. So my other constant that I see in this expression is a plus 1, and 3 plus 1 is a positive 4. Now, I do want to always make sure that I am writing my final answers in standard form, which remember that means that the highest exponent comes first, and then we are descending. So I notice this is actually already in standard form. So negative 7x cubed minus 6x plus 4 is my final answer. When I am adding these two polynomials together. Now, where do we see this in geometry? We see this in geometry when we are looking at the perimeter. So our geometric application is if we are finding the perimeter of a shape, that means that we are adding all of our sides together. So if I am asked to find the perimeter of this triangle, then that means I need to take this side here, 5x minus 3, plus this side here, 4x plus 1, plus my third side, which is 2x plus 10. So this would be my expression for finding the perimeter of this triangle. Now, again, since I'm adding my polynomials, I need to identify my like terms. So my first term is a 5x. I'm looking for other x terms. Remember, same variable, same exponent. So I notice that I have 5x, 4x, and 2x, which are all going to be alike. Now that I know my like terms, I am only adding their coefficients. So 5 plus 4 plus 2 is going to give me 11, and the x will stay the same. The next term that I see is this minus 3 right here, or this negative 3. And notice it does not have a variable, so again, it is a constant. So negative 3, I have another constant that's a positive 1, and I also have a positive 10 as a constant. So I have negative 3 plus 1 plus 10, which is going to give me a positive 8. Again, we always want to make sure that our answer is in standard form, and this is, so 11x plus 8 would be our final answer. All right, for our second application problem, notice that it seems like we are only given two sides of this rectangle. However, we know that characteristics of a rectangle are that opposite sides are the same. So this side is also going to be 8x minus 15, and this side is also going to be 4x plus 6. So if we're given a rectangle, then the opposite sides are going to be the same expressions. So now that means I can add together 8x minus 15 plus 8x minus 15 plus 4x plus 6 plus 4x plus 6. Now again, I'm going to identify my like terms. So 8x, 8x, 4x, and 4x. These are going to be all of my like terms. So notice I have 8 plus 8 plus 4 plus 4, and that is going to give me 24. Remember, your variable stays the same, x. And then next, I'm going to add all my other like terms, which are all constants. So negative 15 plus negative 15 plus 6 plus 6 is going to give me negative 18. Again, I want to double check that this is in standard form, and it is, so my final answer is 24x minus 18. Okay, our last application problem. We are given the layout of some sort of, it seems like a house since it has a living room and a kitchen. And we are asked for the perimeter of the living room and the kitchen. So what we are looking for is the perimeter of this larger rectangle right here. We want the perimeter of both the living room and the kitchen. So notice I am given this side of my rectangle here. We know that each of these is x plus 3. But the other sides of our rectangle, notice that this is 2x plus 1, and then this is x. So if I take 2x plus 1 plus that x, again, we're going to combine our like terms. So 2x plus this is an understood 1. 1x is going to give us 3x plus 1. So that tells me that this entire side length of my rectangle is 3x plus 1, which means that this whole side length here is also 3x plus 1. So now I have all of my dimensions and I can add them together. So I have 3x plus 1 plus 3x plus 1 plus x plus 3 plus x plus 3. So now I want to take my like terms, 3x plus this is an understood 1x plus that's an understood 1x. So 3x plus 1x plus 1x is going to give me 8x, sorry. Oh no. So that's going to give me 8x plus, now I'm going to combine all of my constants. So 1 plus 1 plus 3 plus 3 is going to give me 8. Again, check that we are in standard form, and we are. So our final answer would be 8x plus 8.